We're going to build the Raven today, so look out! Hello kids, Dr. Zoon here. Today we're going to be assembling the Raven rubber band powered airplane. The Raven comes in kit form and has many parts and pieces. It comes in a plastic bag like this. The Raven has many pieces. The largest piece is the wing. It's made from balsa wood, and the wing provides lift for the Raven and helps it fly. This small piece of balsa is the wing incidence shim. It goes between the wing and the fuselage and provides a slight angle for the wing to attack the oncoming air. This trapezoid piece of balsa is the stabilizer. It goes at the rear of the airplane and provides stability while in flight. This triangular piece of balsa is the vertical fin. It helps the airplane to go straight and to be stable. This long rectangular piece of balsa is the wing saddle. It provides a place for the wing to attach to the fuselage. This even longer rectangular piece of balsa is the main fuselage. It's the actual body of the airplane. This long piece of balsa is the fuselage reinforcement. It keeps the fuselage from bending during flight. Also included in the kit is a 7-inch propeller. When this propeller spins, it moves the airplane forward into the air. This long, wide rubber band is the rubber band motor for the airplane. It converts potential energy from the elasticity of the rubber band into kinetic energy, which spins the propeller. These two small rubber bands will hold the wing securely to the fuselage. Tools and supplies that you'll also need to complete this project will be sandpaper, a straight pin about 3/4 to 1 inch long, a sharp utility knife, which of course you want to be very, very careful with. It has a sharp point. A ruler for measuring distances, HD bond or similar white glue to assemble the airplane, scissors for general purpose cutting, and tissue paper, although if necessary you could use white typing paper. The first step in the process of building the Raven is to sand all the pieces. Using fine sandpaper, lightly sand the surface of the wing, the stabilizer, and the fin. Also be sure to sand the edges as well. Make sure that they feel smooth to the touch. Be very careful when working with the balsa, as it is very fragile. We also need to sand the vertical fin on the surface and the edges as well. After sanding is completed, we'll work with the wing and cut the dihedral angles that are necessary for proper wing performance. The top of the wing is clear and has no marks on it. The bottom of the wing is indicated by lines at which we will cut and marks indicating the center position of the wings. The next step in the process is to cut almost completely through the wing with our sharp knife along one line on the bottom of the wing. We place our ruler directly next to the line and press firmly with our knife without cutting all the way through the balsa. We want to cut about halfway or a little farther through the balsa, all the way along the length of the wing. When we have one side cut, we'll move to the other line and repeat the process, placing our ruler right next to the line, pressing firmly with our sharp knife, cutting about halfway through the wing all the way across. We'll turn the wing over, and we'll want to place our hand to this side of where we cut through on the opposite side. Then we gently lift the wingtip up about 2 inches. You will notice that the wood is still intact along the top surface of the wing, but has been broken on the bottom surface of the wing. You must take care not to cut all the way through the wing, or the wing will simply break off. We repeat the process on the other side of the wing, placing our hand next to where we cut through, and we gently lift the wingtip up about 2 inches. We will cut 1-inch wide strips of tissue paper or white typing paper to use as reinforcement on the wing. We'll need about 2 strips 5 or 6 inches long and 1 inch wide. We'll mark the strip to be the width of the wing, and then we'll cut the strip at its mark. We'll repeat the process to make a second strip the width of the wing. We'll make a third strip, again the width of the wing. And then finally, a fourth strip, also the width of the wing. Once we have completed cutting out the reinforcement strips, we'll turn the wing over and we'll fill the cuts with glue. We can lay the wing down flat and run a bead of glue about a 1/2 inch out from each cut. And then place our paper reinforcement strip over the glue and press it tightly to the wood. We repeat the process for the other cut. Placing a second strip of reinforcement paper across that cut. We'll turn the wing over and repeat the process on the top of the wing, placing glue to each side of the cut. And applying our reinforcement paper. Once we apply the reinforcement paper, we need to take our ruler and lift the wingtip to 2 1/4 inches off the surface. We'll repeat the process for the other cut on the top surface of the wing, again applying glue about 1/2 inch out from the cut, and placing the reinforcement strip onto the top of the wing, smoothing it out, and once again lifting the wingtip to 2 1/4 inches above the surface. We'll set the wing off to one side to dry, and if necessary, prop up the wingtip to hold it in place. Once we have completed the construction of the wing, we'll begin construction of the fuselage. The fuselage is composed of 2 balsa sticks, 1 skinny and 1 wide. They will probably be the same length, but the skinny stick needs to be 1/2 inch shorter than the wide stick. If they are the same length, then we'll need to cut 1/2 inch off the skinny stick. Once we have the skinny stick 1/2 inch shorter than the wide stick, we're ready to glue the skinny stick to the wide stick. We need to run a bead of glue along one side of the skinny stick the entire length of the stick. Place the skinny stick on top of the wide stick, glue side down. Be sure to position the skinny stick in the middle of the wide stick and 1/2 inch from one end. Once you have the stick positioned correctly, press firmly down on the skinny stick to adhere it to the wide stick. This end of the fuselage, where the sticks are uneven, is the front of the fuselage. From the front of the fuselage, we want to measure on the opposite side of the fuselage from the skinny stick 3.5 inches from the front end of the fuselage and make a mark. This mark will indicate the position of the front of the wing saddle. To attach the wing saddle to the fuselage, we glue the edge of the wing saddle, applying a bead of glue along the edge, and placing the wing saddle on the flat side of the fuselage, which is opposite the skinny stick, with the front of the wing saddle at the mark we just made. Press the wing saddle securely to the fuselage, being sure to keep the top of the wing saddle flush with the fuselage. We will now attach the horizontal stabilizer to the fuselage at the line which is pre-drawn onto the horizontal stabilizer. Run a bead of glue along the bottom of the fuselage. Invert it. And press it to the horizontal stabilizer along the line. Remove any excess glue at the glue joint. We add a bead of glue to the bottom of the vertical fin. And to the side of the fin, which is next to the fuselage. We place the vertical fin next to the fuselage and on top of the horizontal stabilizer and press it into position. We once again remove any excess glue. We have finished assembling the fuselage and tail section, and we'll set that off to one side and focus again on the wing section. When working with the wing, we need to identify the front of the wing and the rear of the wing. The front of the wing is the shortest of the distances across. The rear of the wing is the wide distance across. At the front of the wing, we want to measure the distance between the two dihedral angles on the wing. We'll place our ruler up to the wing, and in this case, we have a distance of 9 inches between the dihedral angles. Once we have determined the length, which in this case is 9 inches, we want to mark the center point of the wing, which would be at 4 1/2 inches. Be sure this mark is on the front edge of the wing. Find the short wing incidence shim and place a bead of glue along one surface. Position the shim beneath the front edge of the wing with the center of the shim at the mark, and be sure that the front edge of the shim is flush with the front edge of the wing. Press firmly to get a good joint. Once we have completed the wing section, the fuselage and tail sections, we'll set these aside to dry for at least 30 minutes or longer, depending upon the glue that you have used. Once the wing and the fuselage have dried completely, we'll begin the final assembly by placing the 2 rubber bands over the end of the fuselage and slide them back to the back of the wing saddle. We'll place the wing with the front of the wing towards the front of the fuselage on top of the wing saddle. Holding the wing down to the fuselage tightly, pull the rubber band over the front of the fuselage and back down towards the wing. Do likewise with the second rubber band, holding the wing in place and pulling the rubber band across the front of the fuselage and back to the wing. We want to center the marks that we made on the wing over the center of the fuselage. For our initial flight, we'll center the wing over the wing saddle from end to end, like this. You may make minor adjustments to the wing, trying to keep the wing centered above the fuselage and over the wing saddle. To attach the propeller to the Raven, we'll add some glue to the propeller assembly. And slide that assembly onto the front of the fuselage with the hook in the down position. We'll tie the 2 ends of the rubber band motor together in a knot very tightly, and with our scissors cut off about all but 1/4 of an inch of the rubber bands. we'll insert the straight pin about 1 inch in front of the horizontal stabilizer at a 45-degree angle into the fuselage. The pin should penetrate the fuselage by about 3/8 of an inch. We're ready to attach the rubber band motor to the Raven. We'll attach the end with the knot at the pin at the back of the airplane. The other end of the rubber band loop will go into the propeller assembly at the front of the plane. Once the glue on the propeller assembly is dried and we've attached the rubber band motor to the Raven, your Raven is ready to fly. The Raven flies by the power that we put into it in winding up the rubber band. To wind the rubber band, we simply rotate the propeller like this. And you can watch the rubber band wind up. For your first flights, you don't want to wind the rubber band very tightly. You want to make sure that your plane is going to fly very well first. With the Raven, we can show some principles that allow airplanes to fly. Airplanes fly because as airplanes go forward, air passes over the wing, which creates lift. The momentum or the force pushing the airplane forward is provided by the propeller turning. The propeller creates thrust. It pushes against the air molecules, moving the plane forward as it goes. The energy for the propeller turning is provided by your hand spinning the propeller to begin with, and that energy is stored in the rubber band. The position of the wings on the Raven, as we slide them forwards or back, provides a different center of gravity for the airplane. This can change the characteristics of the flight of the aircraft. It may cause a sharper rise, or it may cause a flatter flight. The rear portion of the airplane, that is the horizontal stabilizer and the vertical fin, provide stability and keep the airplane flying straight. You can experiment with your Raven, positioning the wing forwards and back on the fuselage, and also to one side or the other to create curved or circular flights. If you'd like, you can keep a scientist's notebook on the changes that you make to your Raven and what effects that they have in its flight. The Raven is all assembled and is wind up as tight as a rubber band, and it's ready for its first flight. Let's give it a try and see how it flies. Kids, you can have a lot of fun with your Raven rubber band powered airplane. You can take it outside and fly it. Even in a little bit of a wind, it will fly just fine. And if you get it tuned just right, it may fly up to 200 to 300 feet in the air and then glide back down to the earth. This is Dr. Zoon saying, see you real soon.